Welcome to one of our very initial sessions in your personal journey towards becoming an AI applicant. This specific session will be very non-technical in nature. It will focus on the cultural, procedural aspects of AI, and it will also focus on some of the key differences of building and deploying AI as compared to other builds and deployments, for example in engineering, in product build and design, etc. etc. And while we do need these peculiarities for building AI, continuously rolling it out and making sure it continuously improves, we also need to be very careful in nestling this into other kinds of cultures and deployment styles, because AI as such can only be successful through a model of deep collaboration that ensures that all parts of the organization benefit from it. Let's have a bit of a reality check about what the typical expectations with AI are. And typically there are three kinds of expectation on the spectrum. There's a very healthy one in the middle. There is one, and I will single it out very extreme. There's one expectation that basically says, okay, you do AI, so it must be some magic black box and it will just solve everything. And that's certainly not right. Why? We will see in some of the following slides. And there's yet another expectation that says, I have seen so many AI projects fail. It must be that this one also ends in failure. And that's realistic to say. And the key reason for something like that to happen, some expectation building like this, is AI pieces that might even have been really, really good on the methodological side, but not on the cultural side. What really kills most AI teams in organizations is culturally, is procedurally. We need to get into the right mindset of scientific exploration to make AI work and grow into something better over time. So this is a very crude perception. If you would just ask some person on the street, okay, what's AI roughly doing? Well, it should make our work life easier, right? And obviously that is true. But this very simplified version of things that we see here has some crucial flaws that makes many AI applicants, when they start their journey, think that things are going to be easier because they seek the challenges in the wrong area. Nowadays, often the challenges are less on technical measures than on some of the fineries, on some of the ways we deploy. And while it is true that we need to identify a really, really good use case, and that's really crucial to it, we need to analyze the data, build some AI, then to think there's a magic solution that comes out is not typically right. It would be a very, very lucky guess to, in your first iteration, hit that magic solution already. Ultimately, we're going to come there, right? Think about how Google revolutionized the way you're finding data on the internet. Think about other AI solutions. Yes, this makes a drastic impact. But the journey these organizations took to get there was one filled with many disappointments on the way. And that is normal, right? The way we need to cope with this is accept that as part of the process. Now, let's go a bit more elaborative, right? This is perception of an AI process by a typical expert. And the one thing that's already much better here is we see a continuous cycle. And what that really means is continuous improvement, right? I built something, as part of that I learned something, and that learning typically comes from challenges I did not anticipate, or it comes from uncovering something new about the customer as part of the process, right? Because I design the process such that it reveals new knowledge to me beyond the solution I was originally building, right? So this is pretty good, it's pretty smart, but it is very isolated, right? What we see here could be an ivory tower team, right? That sits in an organization, doesn't interact much with other teams or departments, and that is not how AI works in any large organization. That might be the business model of a small startup that has only this one use case, no other products, and has absolute power over everything. What we see much more is essentially we need to accept that the questions that we ask are not going to be perfect. And finding a better question is oftentimes equally or even more important than answering it. Because what AI really is, and that's almost like in Stanley Kubrick's 2001, AI is the most powerful tool of all times. AI is a tool that can solve every single challenge. So now we've arrived at that time where the solution is the easy part. And if I know I can solve almost everything and I can do it fairly fast oftentimes, what then happens is that task that was classically the management's task of guiding where to look happens much more frequently, i.e. it can become a bottleneck, and it becomes even more important than it was before. And that means that we need to democratize this process and also elevate it in our cultural perceptions of all things that happen in the organization. And in the Proof we're already doing that. We're having internal hothouses that focus on asking the right ideas in the beginning. And that, as we have discussed on the circle slide before, is just the first step. Because then once I have found the best question to start with, it needs to evolve, right? And what we're really seeing here is that evolution of getting towards a better question is something that's not straightforward, something that's not expected, but it is crucial, absolutely crucial in reality, to get to the best solution and spend resources wisely. Now to get there, and again get there at enterprise grade, we need to think beyond just single use case. And that is even more important now that everything goes towards ecosystem thinking, towards a collaborative, well-integrated organization with an experimental mindset. And we can see AI is just one of 3 circles to make AI work, right? Ideation, that first crucial finding of the starting point for the question. That is where so many stakeholders are needed, and it is reflected in the breadth of backgrounds that we see in hothouse participants. And clearly hothouses are a major source for this circle. Another major source are our expert communities, our Pulse developers, and our committees and other employee-driven initiatives. Then coming to the AI circle. That's typically very popularized by experts in AI. And these experts spend a lot of time on bringing the data in the right format, cleaning the data. They then spend typically a small amount of time on finding the right model to solve this challenge. And the model, surprisingly, typically is not a copyright. The same thing like you can typically not patent a mathematical formula. Right? What becomes the copyright on the AI side is the combination of the idea, the data, and the algorithm together. Right, so the combination of the three elements is the real copyright. And to test how good that idea works, and for it to be able to learn, and also for the user experience and the quality of the question to grow, we need a third, absolutely crucial circle, which is deployment. And this third and last circle offers us also the opportunity to employ tools like A/B testing, deployment at smaller scale and faster velocities, and thus really enable a safe environment for testing out new things, experimenting, doing things that would be risky, but doing them at a small scale in a controlled manner with tests ensured quality, such that ultimately we can compare all ideas that we have in the company. What that also means as a byproduct is that there's much less internal competition to get ideas heard. Because when the cost of trying out things and the risk of trying out new things gets smaller and smaller, what really happens is everyone's ideas get tested out. And we're seeing this now. We're seeing the differences already with the cultural changes driven by the Pulse initiatives, cultural changes driven by new ways of deployment. We're seeing how more and more ideas get heard. And ultimately, there will be no more need to upsell your idea. There will be no more need to fight for your idea to be the first one, the only one that gets implemented at scale. Because that selection of features, of ideas, is an experimental AI approach as such as well. The customer and the users are voting with their clicks, with their interactions with features. They are giving us data that allows us to learn about better questions, about better user interfaces, better quality of features for every single person. Ultimately, possibly to the level of single person individualization. And that opens up yet another area for AI, that individualization. Let's look a bit deeper into some of these circles, starting with the ideation. And this is something which by now many Peru colleagues actually know quite well, right? We start out and we have a rough idea about an area what to look for. And then, oftentimes, we schedule hothouses. And you all know about the benefits of hothouses or hackathons or similar events, right? The benefit is things are fast, things are creative, and everyone is guaranteed to work together and pull in the right direction. And the right direction is always trying out something that can improve the customer's life. And in a hothouse, we also strive to create a first alpha prototype. And that is something which on a very small scale we can already test and show and get feedback on. And that feedback is crucial for learning. Then after the hothouse, the 90-day period strikes. And it is filled by starting to tentatively improve this area, this new area, the new use case, through some analysis, some scoping. What are additional opportunities? How can we best deploy it? Obviously some approvals are in order. We should never deploy with quality that could endanger our reputation, could endanger even worse customers as such, right? And data need to be brought into one central location where we can merge it. So that we come from data as a cost driver because we're forced to store it, legally obliged to store it, or obliged to store it because our systems must function. We come from that to data as an actual organizational value. The same way companies like Google, like Facebook, have their data. And they sell partial access to it, they sell insights derived from it. And the data becomes a copyright in itself. It becomes an intellectual property at the core of the company. And that whole process is almost guaranteed to yield new ideas as well. So even within that first small closed circle almost, we can already find the first iterations again. And we come back to that point that finding the right questions, asking the right questions is the absolute crucial piece. Now the second circle, the creation of AI. It typically starts out with some research on a methodological level, right? And in the first iteration, this will be limited to just finding some rough model class that works. Typically, the code is readily available, maybe even as a library in a programming language or from a Git code repository. Putting the data together, and crucially, this also includes automating the steps to do that. Because later, when we get new data, it must also be possible to automate the process of adding it to that data repository. Then, and this is typically the step that takes the most time, we need to clean the data. Bring the data in a format that machines can learn well from it. Right? If you would just give a machine, for example, a range of strings, one easy example is gender, male, female. That in itself would not be possible to put in an AI model. What would be possible, however, is if you would translate that and you say, okay, I'm giving the value 0 for man and 1 for female, and you feed that into the model. That becomes something the model can work with, right? So not all values can go straight into the model, but with data cleansing, we have a range of powerful tools that can make almost every kind of data possible for a machine to work with and understand after it has learned from it. And the breadth of this nowadays is phenomenal. A machine can look at images, even movies, all kind of data, be it from the web, be it from scanned PDF files, be it from classical databases, all kind of data can be made workable. And even more crucial, we can build AI that selects which part of that data, which combinations of that data are important to us. And on the other hand, tells us at the same time which data is actually not useful, right? So this is also something cost beneficial, where we can find out, okay, specific data might not be worth storing. Then there's some initial analysis of the data, trying to find out some fresh insights before we get started with the model. And as simple as it sounds, a basic analysis in an Excel spreadsheet on a data in a new format that no one has essentially looked at before is again a very, very rich source of insight. And I cannot tell you how many hours on average this will save you, right? Try doing some basic charts on some data before you put it into a coding language. Redoing the same chart in a coding language has only one advantage: it becomes repeatable, right? That means the initial setup is harder, but every single repetition is essentially for free, right? So in that first analysis phase, take benefit from the fact that you can do charts, possibly even on smaller subsets of the data, in easy environments. Don't be afraid of that. Same thing goes for Googling code or solutions, right? This is an absolute creative environment. Feel free to utilize that. Now, finally we come to the area that is considered AI for most people, right? And that is building the model. And there's a wide range of models available nowadays. Possibly the trickiest part for a new AI applicant is to find out, okay, what is the right model, right? And we will have specific courses on this later, but typically there are very popular models around nowadays, and these are really off the shelf, so it's not something we should be afraid of. Typically there's no need to build your own model, because many of the standard models are well implemented at quality we cannot hope to replicate without substantial work effort, right? And even in use cases where we need custom builds, the typical aim function should be to minimize the customization effort and maximize whatever we can use in a high-grade quality, pre-built manner, as long as it does not stifle our flexibility to a degree that would ultimately inhibit us from iterating the question quality, right? Then, and that next step is the step before which most AI teams stop. And that is the reason why AI teams can become an ivory tower function instead of an integral business part. Because then we're building an application programming interface. What does that mean? Well, it means other coders can access your model, and they can use it to estimate results on new data that you haven't seen before. Right? So what it really means is you publish your model and what it can do. The functionalities become available to other teams and functions. And with that, also to the customer, right? And this is such a profound difference from just doing analytics reports, just doing one-off things, right? It is not suddenly anymore about sending an email to an important sounding person with a one-off analysis. What we have here with an API is a fairly closed module that we can share in interaction, and that then allows us to work on improving the API while it's still running. And crucially, it allows us to collect data from every single interaction. Right? Every time you interact with my code, I can store everything you do, and I can learn from it. And that's really crucial, because only then we learn about how good is the quality of what I have right now. What are the things I can do better as compared to what I have right now, right? And that's really what the last step, design feedback loops, will be all about. But before we get there, let's do one last quality check. And that is to show and discuss. And I would call this a simple sense check, right? What do you have there? If you show it to someone you like, do they get excited? Do they get more or less excited than what you showed them before, right? What's the reaction from a person that is slightly remote from you, right? Some slightly more random selected person in your circle of people you know. What is the reaction from a person who give you guidance on potential risks you could be incurring with this, right? Risks that are not there yet, but possibly with future improvements of this, right? Try and understand where is the roadmap of this going in that last step. And now finally, let's come to the real final step, putting the whole feedback loop together. So your model is done, estimated, smart, more or less, as far as you can push it with data that you manage to gobble together. It is accessible to everyone via the API, and you're feeling at least okay to try it out after that last stakeholder discussion. The one thing that we now need to do is link this together so that the model starts collecting data. It sends that data to a backend, and on the backend we are ingesting the new data, adding it to the existing data set we had before, and re-estimate the same model on that enriched deeper data set. And then don't just assume it's better by default. No, it's not. Actually, models can get worse. With reality data tends to be in questionable quality, right? So one crucial thing in the feedback loop is also have automated quality control gates. Your model quality could degrade due to random fluctuation in the data that you could not foresee before. If that happens, you can see the model's quality of forecasts on the data that you know will degrade, right? In that case, there will be no new model deployment, and there will be an alert email to you and the team to say, hey, have a look, the model is not doing so well anymore after we fed it with some real data, right? And that again is yet another source of really, really great ideas. And another source is also to try out different implementations of your model and try them out in a way that is scaled by how much people interact with it, right? That's really crucial. But now let's come back and say, okay, let's say your model really improved things with the fresh data. What then should happen, and this is the main case of your user journey here, is the model, the better model, trained on the deeper data, gets automatically deployed. And that must be 100% hands-off. Because if it's not, you have not built AI. Right? AI is not just a model. AI is a model that becomes different and changes and gets smarter over time and adapts to changed circumstances. So really AI is the combination of data, a user interaction interface, a model, and the feedback loop to make it all work together in an evolutionary fashion. Right. So that's it for today. I hope you enjoyed this session on AI culture. We're looking into preparing more of these sessions in the near future, and as always with AI, I will appreciate your feedback and improvement ideas. Thank you so much.